that we plug these devices up to, and we're going to add an interesting thing called a router. What's a router's job? Its job is to send traffic from one network to another. That's the job of a router. So here's router 1 sitting here. Now this particular interface is going to be configured for network B. And this interface over here is going to be configured for network A. And the router's job is to send traffic from one network to another. Now remember, a router can only have one interface in a particular network. So if network B is on this particular interface, I cannot have another interface that belongs to network B. And again, these networks are defined by an IP address. So if I have an IP address of 192.168.1.x, and over here 192.168.2.x, because the way I assign these IP addresses, they're on two different networks. They will not be able to communicate with each other, which means if I had all these PCs sitting on this switch and I gave it an IP address of 1.x and gave it of 2.x, which would be 192.168.1.x and 192.168.2.x, these two PCs, even though they're sitting on the same switch, will not be able to communicate with each other. It won't happen. That's TCP IP doing its job. It will not allow that communication. But in our example here, I got them on two separate networks. I got to have a interface of that router on network B. I have to give it an IP address that belongs to network B and plug it into the same switch as the other devices are sitting on. Same thing for network A. If I had network A, or an interface on router 1 with network A, it would plug into the same switch as the other PCs will plug into. So when any of these PCs need to communicate with network A, it will send that traffic. Let's say PC8. PC8 says, hey, I'm trying to communicate with network A. Guess who he's going to send it to? He's going to say, I'm going to send it to router 1. Because router 1 does the communication between networks. And network A isn't on my network. So I know I have to send the traffic to the router. The router looks at it and says, oh, you're trying to get to network A? Hey, I'll take care of that. And I'll send it right on into the switch. And that traffic will find its way where it needs to go over here to PC3. And this is how all our devices fit together. This is the basics. Now, at any given moment, you can have yourself a firewall here. And you can slide that bad boy here. Which means that anytime traffic is going out of this router into this network, it has to go through this firewall. And this firewall gets to decide what traffic is allowed, what traffic is not. Again, that's just something I added. It's not really necessary, but it's good to know. Because as network guys, it's very easy to forget about firewalls. Very easy to forget. And I mean very easy. So technically we already talked about the purpose of the switch. And that purpose is for us to have multiple PCs to communicate with each other. If this was a 24-port switch, we will be able to have 24 PCs plugged into this switch. Now, once you do that, though, you have no more spots. Which means if I had 24 ports all used up, there's no way these PCs will be able to communicate with any other network because you would need a router to plug into this switch. And guess what? A router takes up a port. Now, if that router takes up a port, how would I fix that problem then? Well, that means I would actually have to get another switch, plug that switch into this, plug that 24th PC into here, PC 24, plug it into here, and there we go. So now this will be port 24 on this switch. This will be whatever port you want, whatever port you want. That's what I will have to do. I'll have to add another switch to make this happen. And that's the nice thing about it, because we can add switches and connect them together, and we can turn our 24 port capability into 48 ports. Isn't that nice? Anytime we want more PCs, we just add another switch, switch 2, and connect it to switch 1. And now you have how many connections? Like I said before, you're going to be using one up for the switch. You're going to be using one for this switch, and you're going to lose one for the extra PC that goes in there if this was already filled up. But that still gives you 22 extra ports. After you've removed this off of this switch, plugged it into the new one, and connect the switch up. So the purpose of a switch is to give us many possible connections. Now the switch does a lot more than that, which is what we're going to find out later on, but for this purpose, this is the idea of the purpose of the switch. So you as a green person, which means you're green, you're brand new, you're a novice, you're a newbie, and I tell you to go pick up a switch out of the closet, maybe in storage, please go pick up a switch. You know that a switch is something that needs to connect many ports together. You're going to be picking up the one that has lots of ports. You're not going to be picking up the one that has 1 or 2 ports, because most likely that would be the router. So let's see how all this fits in even more. Now this concept, what we have here, notice how we have a drawing, a network diagram, starting from here. Here's PC1. Now, think of your home. You have a PC, you plug it into the switch 1. That switch plugs into it, also has a router plugged into it. Now, in your scenario, you're going to have a switch/router, which means instead of having 2 separate devices, your CCNA is always going to be 2 separate devices. You're going to have a router and a switch. They're going to be separate. But your Linksys device, your Fios device, your Comcast device, your Cox Communication device, your Sprint device, whoever you're getting internet service from in your home is most likely going to be this kind of device sitting here with antennas coming off of it, and it's probably going to have these switch ports on the side, probably 4 switch ports. And that's pretty much it. You're going to have the cable, and you're also going to have this WAN port. We call that the WAN, W-A-N. Okay, and that plugs into your, whoever's providing you your connection. Now, let's say it's Comcast. So we would draw this cloud and write Comcast in it. So we know that this is our WAN port, that this connection is coming from Comcast. We care about this port that's sitting in our house, but after it leaves this wire, we don't care where it goes and how it gets there. We don't have an idea, and we don't want to have an idea. We don't care. Now, these extra 4 ports, or 3 ports, let's make another one here. These extra 4 ports just gives you the ability to plug things in. But most of you guys will use the wireless section of it. These are your switch ports. And the box is the router itself. So it's a router / switch. Okay? Now, as this PC, which is PC1, he's going to send communication and try to talk to PC2. Now, because they are on the same network, or the printer here, are on the same network, that traffic is going to go up, hit the switch, come back down. If he's communicating with the printer, it's going to come up and come back over here. And the router was never concerned with the traffic, and the router would never get the traffic. But if PC1 wants to go out and hit the internet, you're going to type in www.yahoo.com. But remember, you might be typing that in, but it is getting resolved to a IP address. You might be putting names into your browser, but that name is being translated to an IP address. Your PC would do this. It's like, look, I'm trying to communicate with www.yahoo.com. It'll look up the actual host name, which will be yahoo.com, and find out what the IP address of Yahoo is. Then he will actually send the information out to the IP address. Let's say it's 1.1.1.1 is for Yahoo. And the PC is going to look at it and say, well, wait a minute. 1.1.1.1 is not on my network. So where will PC1 send it? The only place where that can send traffic between networks. They'll send it right to the router. The router will get that information and says, oh, you're trying to get to 1.1.1.1. Okay, I know for that traffic, it needs to go out this interface here and send it out to the cloud. To Comcast. Comcast will hand it off and the data will go from there. And you would figure, well, that's a lot of steps for this to go. There's a lot more steps than that. And you still get your web page really fast. So with this, all of this stuff sitting at this router and below is called a small office home office. Now, as a network engineer, most likely you will never set one of these up. As a PC guy who goes around and fix people's PCs, he would set these up, but not in the fashion that you would. I mean, he would go out and get a Linksys router, because that's what I used to do back in the 90s. I would go out and buy them these Linksys routers, thinking that I was good at networking. I didn't really understand what networking was until I started getting into CCNA training. And boy, it's a magical world. But this small office, home office, some large enterprise networks, you have VPs or people who work from home, and they're going to have a router, but they're still not going to have that Linksys router. You're going to take a real router, like a 2800 or a 2900 or a 1900. It's most likely going to be the 19 series or the 18 series, and you're literally going to have a router and a switch and PCs and printers plugged into those switches like this, just like this. This will be the concept of a small office, home office. We say that because of the fact that small offices will have this type of setup as well. Now, don't get me wrong. This concept of a router hooked into a switch is what we base all our training on. But the reason why SOHO is important is just the fact that we understand that it's small. Is it really important for you to understand this? It's just a term that's in the book now. That's the only reason why I brought it up. That's it. But you need your switches to communicate between each other, and you need a router to get out of that network to go somewhere else. So this will kind of be your design. In most cases, I'm going to have a PC, I'm going to have a switch, I'm going to have a router. So I said several times the concept of Ethernet. And this is what we're going to discuss in our next section. Because the network fundamentals, Ethernet does have a part of this. In fact, you know what? No, we're gonna continue on, because actually all this is network fundamentals. So we're not gonna end right here. I was thinking about making this a second chapter, but there's no point. So Ethernet, let's talk about that. Ethernet is the means of how data is moved across a media. What is a media? When you had your beautiful tapes here, okay, what is this? This is kind of like your little tape that you used to put your music on. This is a media. Then things got fancy and we got to CD-ROMs. This is a media. But even before our tapes, what did we have? We had records. And then we got from CDs, and then we got to what? Big old laser disc, right? We got a big old laser disc that we could use. And then we got to what? We got to these nice little small, tiny flash drives. And there's lots of different types of medias in there, but these are medias. Okay? It's where our data is stored. But in this concept, media means what are we sending the data across? Because in the networking world, we're not just holding data. We're not storing it. We're sending it. So if I send this over a fiber cable, our media is fiber. If I send it over an Ethernet cable, well, that's funny because we call it Ethernet cables. This becomes a term that we use as a means of saying, okay, we're using a Ethernet cable. But really, it's what we call it is twisted pair cables, or another word would be Cat 5, Cat 6. And of course, you got Cat 5e and Cat 6e, but all it is a cable. That's it. Cat 5 and Cat 6 are twisted pair cables. We call them Ethernet cables because normally we use Cat 5 and Cat 6 to plug into our Ethernet ports. And since we're plugging that cable into our Ethernet port, we are calling it an Ethernet cable. But we don't call it Ethernet fiber, do we? Even though we're running Ethernet over fiber cables. It just happens to be a term that people just started to get used to and just started saying Ethernet cable. But in your world now, in our world now, you're going to start calling them, you can call them Ethernet cables if you want, but you're going to start calling, saying Cat 5 or Cat 6. Definitely understand those terms, which we're going to be talking about those anyway, shortly.